Hi Mrs McTaggart. This video is going to look at the higher topic of differentiation, and in particular we're doing curve sketching. So this is a lesson that would come straight after having already been taught how to do stationary points and nature tables, alright? So we sometimes get asked to sketch them, and we also sometimes get asked this thing here on this question, where I've said to sketch the curve y equals x cubed minus 3x squared and describe how the curve behaves for large and positive values of x. So it's a little twist. But the fact we've asked to sketch it means we've got something extra to do as well. So we'll talk about all these wee bits at the end. Meanwhile, we treat it like a normal stationary point question and do all the steps from before. So remember, step one for a stationary point is to differentiate. So this one is in terms of y. So we get dy by dx equals, now if you differentiate x cubed times by the power lower the power, 3x squared, take away 6x. And remember your statement for stationary points, I'm just going to write SPs for short. So for stationary points, dy by dx equals 0. So remember, we should always write that little sentence. 1, it could sometimes get you extra mark, and 2, it reminds you what to do next. So we now set this equal to 0. And remember, this is now factorising. Common factor, difference of two squares, trinomial. In this case, it's a common factor of 3x, leaving you with x take away 2. So when you break that up, the first bit gives you x is 0, second bit gives you x equals 2. So to get the second part of your turning point, you sub these numbers back into the original equation, which is up here. So when x is 0, well, y is just 0 because it's 0 minus 3 times 0, so 0. So there's your first turning point. And when you sub in the number 2, that would give you y equals, well, 2 cubed is 8, 2 squared is 4 times 3 is minus 12, so that gives you minus 4. So your other turning point is 2, negative 4. So our nature table is missing a little bit here. It should say dy by dx because we're using y this time. Along the top of your nature table, you do anything up to your x values, so anything up to 0, up to 2 and beyond. Your gradient of these bits are both 0. Now at that point, I'm going to go kind of just talk about what numbers I'm going to use. So if I'm using a number less than 0, I'm going to plug in minus 1. Between 0 and 2, I've got no option other than to plug in 1. And after the number 2, we could just use 3, or remember, to make life simple, you could use a number like 10 or something like that. So when I go to do my substitution, this next little bit in red working is optional. It's just to show you where I'm getting these numbers from. So if I plug in f dashed minus 1, remember I'm plugging it into this bit here. This is where I'm substituting into f dashed x. If you put minus 1 in there, well, minus 1 squared is 1. So you've got 3 times 1, take away 6 times minus 1. Now that becomes a double negative, so you have 3 plus 6, so that's positive. If I do the same but plug in the number 1, you have 3 times normal 1 again, take away 6 times 1. Well, that's 3 take away 6, so that's negative. And then if I use the number 3, well, 3 squared is 9, 9 times 3 is 27, take away 6 times 3 is 18, well, that's positive. So my shape looks like this. So the last bit to do here is my conclusion is to write out my 2 turning points and their nature. And I know I've already got them written over here, but I just like to write them under my nature table. So 0, 0 was a maximum turning point. And the other one was 2, negative 4, which was a minimum turning point. Okay, so there are my 2 stationary points. Next, to sketch this, I also need to think of where it cuts my x and y axis. So I'm just going to rewrite my equation again here. So it was y equals, oh my goodness, x cubed minus 3x squared. So x cubed minus 3x squared. So once we've got a diagram, we need to know where this curve already cuts your axis. Now, I always get my pupils to write this little statement that it cuts the axis when x equals 0, when y equals 0, because that's kind of reminding you what steps to do. So our first step is to do exactly what I've written there. We're going to say put x is 0. So when x equals 0, plugging in 0 to your equation just gives you y equals 0 cubed minus 3 times 0 squared is just 0. So I know it's cutting at 0, 0. Now that's already come up before as one of my nature One of my stationary points. Don't let that put you off, okay? A lot of the times your stationary points are on one of your axes, so it should come up again. Right, next I put y equal to 0. And that makes it a wee bit trickier because you have to then do some factorising. So we have x cubed minus 3x squared equals 0. Well, that's got a common factor of x squared, leaving you with x minus 3. If you split that up, we've got x is 0 and x equals 3. So you have roots at 0, 0 coming up again, and 3, 0. Right, so to do our sketch, I start with your nature table, your stationary points. So these should also see x and y axis properly, probably. So at 0, 0, at your origin, we've got a maximum turning point. At 2, negative 4, we had a minimum. So 2, negative 4 is somewhere down here, so we had a minimum. Now, to join this up, well, that would have started from maybe down here, and then it'll come down and turn and go up again. So that's a good enough diagram. And all you have to annotate on is your turning point at 2, negative 4. I don't need to mark on the 0 because as long as I'm going through the origin. And the other thing I have to put on is your root here, which was 3. So there's my graph cutting at 0, 0 and 3, 0, turning point at 2, negative 4. Now the last wee bit here is asked, well, what's going on when x is large and positive? Look at my diagram here. When x is large and positive, what keeps happening is if I continue that on and make x absolutely huge, then y is just going to get bigger as well. So y is also large and positive. And similarly, if I'm wanting x to be large and negative, so if I keep continuing this way, then y just becomes a bigger number. So it also becomes large and negative. And another way of writing this is we could say that as x approaches infinity, then y also approaches infinity. And similarly, if x approaches negative infinity, then y approaches negative infinity as well. It's a short way of writing that, but I prefer the words. Right, let's look at another example. Okay, this example is not ready to even think about differentiating until we expand those brackets. So we should have f of x equals x bracket, that would give you x squared plus 3x, so that's 6x plus 9. And then if I introduce x, that goes to x cubed plus 6x, plus 6x squared plus 9x. I had a wee silly moment there. Now we differentiate. So it goes down to 3x squared plus 12x plus 9. And then remember the wee bit for stationary points. We set f dashed x equal to 0. I'm going to take out a common factor of 3. So 3 bracket x squared plus 4x plus 3 equals 0. Two numbers that multiply to 3 and add to 4, well, it's just going to be 3 and 1, and both positive. So from there, that gives me x equals minus 3 and x equals minus 1. Remember that 3 at the front is just a multiple, so it gets dropped. It's not going to be split up with the other brackets. So there I've got those two numbers. I have to plug them back in to get my y coordinates. So if I put minus 3, remember you're putting it back into the very original equation, so I'm putting it in here. If I put in minus 3, well, minus 3 plus 3 is 0. Square it is 0. Times it by minus 3 is still 0. So my first one gives me minus 3, 0. If I plug in minus 1, then minus 1 plus 3 is 2. 2 squared is 4. 4 times minus 1 is minus 1. No, 4 times minus 1 is minus 4. So my other turning point is minus 1, minus 4. Okay. Right, my nature table. So I'm doing anything up to minus 3, anything up to minus 1, and anything beyond. So into f dashed x, where is f dashed x? This is here. So this is where I'm substituting into, that's my f dashed x. So at minus 3 and minus 1, we have 0. let's think of numbers to put in. I'm going to go very simple, and I'm going to plug in a minus 10 here, because it's much easier to plug in minus 10 than it is to plug in minus 4. So if I plug into minus 10, let's do some working just to show you what's going on. So f dashed of minus 10 gives you, well, minus 10 squared is 100, so we've got 300. Then 12 times minus 10 would turn that into minus 120, and plus 9, well, don't care what you say, that's positive. Let's do it with a number between minus 3 and minus 1, so we're going to have to do minus 2. There's not much options here. So f dashed of minus 2 is minus 2 squared is 4, 3 fours are 12. That will then give you minus 24 and plus 9. Well, that's negative. And then a number bigger than minus 1, let's just go with 0. So f dashed of 0 would give you 0 plus 9, which would be positive. So I've got up, along, down, along, up. So my nature of the turning points is minus 3, 0 is a maximum. And minus 1, minus 4 is a minimum. Okay, so next is trying to annotate the other bits onto the diagram. So I'm just going to move this up a wee bit because I've got everything I need here. I might have to redraw that diagram though from axis. Okay, so to find where your roots are and where it cuts the y-axis, always write this little sentence: cuts axes when x is 0, y is 0. So first step is put x is 0. That just gives you y equals 0 times 3 squared. Well, that's just 0. And remember what I said, quite often one of your turning points comes up again because it's also a root or a y-intercept. Then we put y equal to 0. This is a bit that requires a wee bit more working, so that leaves you with this thing here equal to 0. Now, it's already factorised, so there's no point multiplying it all out. We're going to break it up now. So this one gives you x is 0. This one gives you, well, it gives you x plus 3 all squared is 0. So you would then do the square root of 0 is 0. So you end up with just x plus 3 is 0. So x equals minus 3. So you've got, there's that 0, 0 again. And then minus 3, 0. And minus 3, 0 actually was one of your turning points. So let's go do our little coordinate diagram. So I've got my two axes there. This will actually work out okay. So at minus 3, 0, we have a maximum. So I'm going to mark on that that is minus 3. At minus 1, minus 4, well, that would be somewhere about here. And that would be a minimum. And we said it cut at minus 3. We also said it cut at 0, 0. So when I join this up, I need to make sure it goes through 0, 0. So there is my kind of shape there. That's not bad. Always good to do in pencil, and then you can go over it again. So there's my diagram with my x and y axis. The only thing left to annotate is that that is minus 1, minus 4. So that's me done. If you are wanting any practice on this and you've got the access to the TJ book, I would recommend going doing these questions. You might be wondering why I've put N before L. It's because L is a bit tricky compared to the others. I think L comes out with irrational numbers for your roots, so you might end up with something you can't really do. So I think you end up with a plus or minus square root of 5 over 3 or something like that for that one. So just be aware they're not always nice numbers for your roots. Thanks for watching. Bye bye.